Hello students, welcome back to AriserTalent. I am your maths teacher Arpita Sharma. Student, today we are going to summarize our chapter that we have just finished, that is trigonometry. Okay, so when we talked about this chapter trigonometry, first we understood the basic concept and the right angle triangle, and then we knew about the different aspect of the right angle triangle, different ratios. So we basically studied trigonometric ratios and the related identities. Okay, so as for the summary, in the first we understood that trigonometry is basically a word of mix of three subwords, you may say, like trigon and metron from Greek, and that's tri means three, gon means sides, and metron that means measure, that means something containing three sides. Okay, so measurement about the containing of three sides, that means the measurement of a triangle is basically what does trigonometry mean. Okay, now the ratio of sides of a right angle triangle with respect to acute angles are called trigonometric ratios of the angle. Okay, then we studied the right angle triangle. What is the right angle triangle? In which we are having one angle equals to 90 degree, and in that particular triangle the sum of other two remaining angles will be what? 90 degree. The sum of other two remaining angles other than the right angle will be also 90 degree. Okay, so correct it here, this is triangle, not pi here. Okay, and yes, so a triangle having one angle equal to 90 degree is called right angle triangle. Okay, this is the basic. The sum of other two acute angles that I have told you is 90 degree. The side opposite to 90 degree is called hypotenuse. So basically we were having this we were having this 90 degree, this angle equal to 90 degree, and this was our right angle triangle. So this side just opposite to this right angle will be hypotenuse. Okay, then the side opposite to the given one acute angle is perpendicular, the rest is base. So if I consider this angle, so for this angle, this is our base. If this is theta, then this is our base and this will be our perpendicular. Okay, the base is one on which the theta resides. If I will change this theta, and let us suppose our theta is this, so for this theta the base will be this and the other remaining will be perpendicular. Is that clear? Okay, now note it. Okay, so here there were three you can say way you can represent it in this way. This is the perpendicular, the hypotenuse, okay, and the base. Okay, in this case this will be the hypotenuse, theta is this, so perpendicular will be that side and that will be the base. In this condition theta is this, so base will be this and the opposite to 90 degree will be hypotenuse and the remaining side will be the perpendicular. Okay, so from the figure you can have the perpendicular base and hypotenuse. The trigonometric ratios, what are the trigonometric ratios? I have told you about the trigonometric ratios, that basically they are sin theta, cos theta and tan theta. Then we talked about these sin theta, cos theta and tan theta, that the P by H is sin theta, B by H is cos theta and P by B is tan theta. Now we are having again cot theta, sec theta and cosec theta. So inverse of tan theta, that means 1 upon tan theta is what? Cot theta. Cos theta is what? Cos theta is 1 upon sec theta, and sin theta equals to 1 upon cosec theta. So you can say that cosec theta is equals to 1 upon sin theta, and similarly sec theta equals to 1 upon cos theta. That means if we talk about these trigonometric ratios, here will be cot theta, And cot theta is inverse of tan theta, that will be b by p. Okay. Similarly, here cosec theta, the inverse of sin theta, that will be h by p, and here sec theta, that will be h by b. Right? These formulas are clear to you guys now. So, these ratios sin theta, cos theta, tan theta, cot theta, sec theta and cosec theta are the basic ratios that we will be talking about in complete chapter. Okay, and be very specific about the revision of this, because I have told you in the starting of this chapter that this chapter is containing the basics of your 11th and 12th classes. Okay, so be very particular about that. Here, all these are pi, just replace it with theta. Okay, these are the value of sin theta, cos theta, tan theta, cos theta, sec theta and cosec theta that I have told you, and these are what the sides as per given the figure. So, just forget about this and just remember this p by h, b by h, p by b, b by p, h by b and h by p for sin, cos, tan, cot, sec and cosec. Okay. So, we have concluded that these are the inverse of the sin theta, cos theta and tan theta respectively, cosec theta, sec theta and cot theta. Okay. So, we can set trigonometric ratio represent ratio between the acute angles and side of triangles. Moving towards the notes, we are having these small conclusions. The value of sin theta and cos theta are always less than or equal to 1 and greater than or equal to -1. How we concluded that? We are going to have a particular table of the values of sin theta, cos theta and tan theta, and also sec, tan, sec, cosec and cot theta. Okay. So, value of tan theta and cot theta lie between -infinity to infinity. Second point. The third one is sin A, cos A. These are not multiple. If you are writing this sin A, this does not mean that we are multiplying sin by A. No, it is not like that. Okay. Sin is a complete term. Okay. Similarly, sin A square. Similarly, sin A whole square, that cannot be written as sin A square. Sin A square is different thing, sin square A is different thing. That means if you put this, if you write this is what we are writing like sin A whole square. These two are same, but these two are not same. So, note the difference between them. So, some specific angles, if we talk about 0 degree, 90 degree, 45 degree, 30 degree. So, these specific angles are having some particular values that we have talked about, that if we talk about sin, cos and tan. And should we write the values here of sin, cos, tan, cot, sec, cosec. Now you know how to make this table. 0 degree, 30 degree, 45 degree, 60 degree and 90 degree, right? Okay. So, now you know how we will make this table. Okay. Right. So, what will we do? We will write just value 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. Okay. This was the very first value that you remember. Now, that the opposite thing. Okay. Root 3 by 2 here, 1 by root 2 here, 1 by 2 here and 0 here. Now, for tan theta, what is tan theta? Sin theta upon cos theta. So, 0 by 1 is 0, 1 by root 1 by 2 divided by root 3 by 2 is what? Root 3, okay, that is 1 by root 3, okay. Then 1 here, that will be root 3, here that will be infinity or not defined. Here what is cot theta? 1 by tan theta, 1 by 0 is infinity, okay. Here that will be root 3, that will be 1, 1 by 1 is 1, okay, 1 by root 3, and 1 by 0 is infinity. So, reverse of 1 by 0 is 0. Sec is inverse of cos, so that will be 1, that will be 2 by root 3, this is here root 2, here it will be 2 and here it will be infinity, right, okay. Then we will talk about 0, so that will be infinity here, cosec, okay. So, that will be infinity here, 2 root 2, 2 by root 3 and 1. So, these will be the values of these specific angles, okay, and these are the values that will be of your use when you will be solving the questions, okay. So, this was the table, just check it here, right. And after that, if you talk about second cosec, 1 2 by root 3, the root this one sec. Yes, here I have talked about this earlier also. Correct this value, that is 2 by root 3, not 1 by root 3. Okay, okay, and this value, right? Okay, now, so here, if we talk about sin theta, the value is increasing. If we will talk about cos theta, the value is decreasing. Okay, from 0 to 1 here and from 1 to 0 here. Okay, so these are the values. Tan theta, cot theta are defined for 0 equals to 90 degree, are not defined for 0 equals to 90 degree and 0 degree. Tan theta is not defined for 90 degree and cot theta is not defined for 0 degree. Similarly, cosec theta, sec theta are not defined when theta equals to 0 degree and 90 degree respectively. Sin theta equals to cos theta for angle 45 degree, because at the angle 45 degree the value of sin theta and cos theta is same. This is 1 by root 2 and okay, 180 is what? 180 degree, what we can write, 180 degree is equals to pi. So, we can write, if we will write this 0, that will be 0, okay. If we talk about this, that will be pi by 6, that will be pi by 4, right, pi by 3, pi by 2, okay. So, these values can be written like that. Then we solved some formulas and then we talked about complementary angles. What are complementary angles? If the sum of two angles A and B is equals to 90 degree, then these two angles will be known as the complementary angles. So, we are having some identities, we use these identities to solve the questions, okay, for the complementary angles only. We know complementary angles are the pair of angles whose sum is 90 degree, like 40 degree plus 50 degree, 90 degree, 60 and 30, this is one pair, 20, 70, this is one pair can be, and 15 degree and 75 degree can be one pair. Similarly, we can make infinity pairs that whose sum is equals to 90 degree. Now, formula: sin 90 minus theta is cos theta. Sin 90 minus theta is cos theta, cot 90 minus theta is tan theta. If you talk about sin, cos, tan, in case of sin that will be cos theta, in case of cos that will be sin theta. Inverse of each other, okay. In the case of tan that will be cot theta, okay. Again in case of cot that will be tan theta. Tan, from tan to cot and from cot to tan. In case of 90 minus theta we are talking, okay. Here sec and cosec, again 90 minus theta is cosec theta, again cosec 90 minus theta is sec theta. Sin, from sin that will be becoming cos, from cos to sin. Similarly, tan to cot and cot to tan. Here sec to cosec and cosec to sec, okay, note it, okay. And if we further move towards the trigonometric identities, this one we know, tan theta equals to sin theta upon cos theta, and then sin square theta plus cos square theta. We use this identity in many questions, so remember that is equals to 1, that again we are having 1 plus tan square theta equals to sec square theta. 1 plus tan square theta is equals to sec square theta. Similarly, 1 plus cot square theta will be equals to cosec square theta. Okay, so you have to learn these identity. This is the linear identity, because this is a linear one, okay, linear equation. And if we talk about these three, these are the square identities, these involving a square or two square terms. Okay, here we proved these identities, and these identities you also have to remember, because you can use these identities directly in other questions. And okay, this one we proved, again we proved. So in this, what we did, we bifurcated in the sin square theta, in sin theta raised to power 4 whole square minus cos theta whole square 4 whole square 2. So basically we made it a square minus b square, and then we bifurcated as it like a plus b and a minus b, and then we put sin square theta plus cos square theta equals to 1. So in these kind of questions we used other identities, okay, to prove another side. Okay, we took one side and we proved another side. Okay, so this was the short brief, or you can say this is the summary of the chapter, and we did so many numericals based on this theory. Now what you have to do, revise this theory lecture completely and do questions based on these theory from your AriserTalent sheet. Okay students, take care of yourself. Bye bye.